All right, so I'm just going to take you through the quadrilateral flow chart and kind of define some things and point some things out. So we're going to go piece by piece here. But before we do that, let's take a look at this note down at the bottom here. It says, once the property is listed, it filters down through all the shapes. So basically, if it starts in the quadrilateral, so look at the quadrilateral all the way at the top, it says four-sided polygon, and then the sum of the interior angles is 360. So those two properties are going to be the same for the trapezoid, the parallelogram, the kite, the isosceles trapezoid, and everything down below it, even though it's not listed under those specific shapes. Those two things are still properties of it. So just keep that in mind as we go through this, and pause and ask questions as you have them. So quadrilateral, we know four-sided interior angles add up to 360 degrees. So there are many different types of quadrilaterals. There are 7. We're going to take a look at, first of all, the parallelogram. This group right in here are kind of like the family of 4 in a way. Okay, they kind of all go together with the exception of the kite. So we're going to take a look at the parallelogram first. It says both pairs of opposite sides are parallel. So that just means that they're going to go in the same direction. So keep in mind when we have opposite sides are parallel, we've got a bunch of different properties of parallel lines that will still apply. Like the consecutive interior angles are supplementary because we know that this angle right in there and the one that's right next to it are going to be supplementary. Same thing with if you go this one on the left and the one on the right, that's going to be supplementary as well because they're one right after another because of those lines that are parallel. If we extend these, and then that looks like the transversal. Okay, if you kind of flip your head around, you might be able to see it. So consecutive interior angles are supplementary. Opposite sides are congruent. So not only are they parallel, but they're congruent as well. The last one is diagonals will bisect each other. So remember, diagonal is something that connects each the vertices that are across from each other. So if I connect this vertice to the one across from it, and same thing with this one over here, the diagonals bisect each other. So this is going to be, those two sides will equal, and then those two sides will also be equal. Now, they're not all equal to each other, just each different part is congruent to each other, okay? So that's the parallelogram. Let's go down to now the rhombus. So a rhombus is a parallelogram, so it has all of the properties listed above. But the special thing about a rhombus is that all the sides are congruent. Okay, so all the sides are congruent. Still, the opposite sides are parallel. So like I said, still has the same properties as a parallelogram. The diagonals get a little bit more specific. So if I create the two diagonals, not only do they bisect each other, but they are perpendicular bisectors. So that means that they form a right angle. So you have 4 different right triangles in your rhombus, and all of those right triangles are congruent. So if we go and find the area of this rhombus, you just find the area, you can find one of the areas of those little triangles and then multiply by 4. Okay, I think and the last one that I forgot to do is diagonals bisect the angles. So these diagonals that go through the center and that are perpendicular, they're going to bisect the angles, meaning that those angles are going to be congruent. And then these angles that I'm marking with a double arc are going to be congruent as well. Okay, so getting even more specific. Now we're going to look at the rectangle. So rectangle, same properties as a parallelogram. You're very familiar with the rectangle. All the sides meet at right angles, and then the diagonals here are congruent. Okay, they don't bisect, well, they'll still bisect each other because the parallelogram property. So they're still going to bisect each other, and they're going to be congruent. So all the different parts of the diagonals are going to be equal. Okay, Now a square is a combination of a rhombus and a rectangle. So basically if you smush those two together and basically took the average of them, you're going to get a square. You're very familiar with a square in the fact that all the sides are equal and everything meets at a right angle. That's why it's very similar to a rhombus, because all the sides are equal and then it's got the right angles from a rectangle. But the diagonals of a square, if we draw those in, so the diagonals are congruent just like in the rectangle. The diagonals are going to bisect each other. So that means each little part is congruent just like the rectangle. They're going to meet at a right angle just like the rhombus. So what you see here is you'll see 4 different isosceles triangles. Okay, again, those triangles are going to be exactly the same as like the rhombus where you have 4 of the same ones. These are just a little bit more specific because they are isosceles right triangles. Okay, so that's the parallelogram family. Now let's go ahead and take a look at the kite before we switch over to the other side. So the kite is still a quadrilateral. It's not a parallelogram because opposite sides aren't parallel. This first property says 2 disjoint pairs of consecutive congruent sides. It's fancy language for sides right next to each other are congruent. Okay, so like say this one is 5 and this is 5. Could be 12 and this could be 12. Okay, 2 sides right next to each other are going to be congruent. That's what that first one means. The definition of perpendicular and the diagonals bisect each other. The diagonals that are bisecting each other, they don't necessarily bisect each other, they just bisect one. So the longer one, in this instance, KT, is going to bisect the smaller one. So that IE got cut in half. KT didn't get cut in half, it did the cutting. Okay. In addition, it's also going to be perpendicular in there as well. So again, you've got 4 right angles inside your kite. But the major thing is that you know the longer diagonal is going to cut the shorter diagonal in half. Okay, and the last 2 are kind of go together. It says the diagonals bisect opposite angles, and then one set of opposite angles are congruent. So if we're looking at this kite, the ones that get bisected are the top and the bottom ones. Okay, those are the ones that get bisected. So the diagonal that bisected the other diagonal, so like we said, KT bisected IE, KT also bisects the angles. Okay, so you can think of just matching that up, figuring out which one bisects the diagonal. That diagonal will also bisect the angles. Then the angles that didn't get bisected, those are the ones that are congruent. Okay, so kind of opposite. There's a lot of things going on with the kite. So you just gotta look at it, you gotta study it, you gotta study the different properties. Okay, so that's kind of like the right side of the flow chart. Those 5 go together. Here's a key down here if you don't know what the symbols mean: the angle, the congruent, the parallel, the perpendicular, all that stuff. So keep practicing, keep looking at the figures, keep asking questions. The more you look at these, the more you do the problems, like everything, the more comfortable you're going to get. But with these, there's so many different things to remember. You just got to attack them. Okay, let's go to the left side. I call these the oddballs because they're not really parallelograms, but they're still quadrilateral, so you got to include them. The first one is called a trapezoid. We're very familiar with these. Trapezoid just has one pair of parallel sides. The other 2 sides are not parallel. They're not congruent. They're not anything. So this has the properties of parallel lines still. So if I extend these lines, okay, and act as the other sides are like the transversals, we know that this angle and this angle are supplementary, and then same thing with this angle and that angle. That's also supplementary. Just because you have those parallel lines, you're still going to have those properties that we talked about a couple weeks ago. To get more specific, we're going to talk about the isosceles trapezoid. So if you look at this picture here, you've got two bases and two legs. The bases are going to be parallel, just like your regular trapezoid, but your isosceles trapezoid means you have two legs congruent, much like your isosceles triangles. Okay, and again, just like your isosceles triangles, so if I draw one up here, and here are the two congruent sides, that means these base angles are congruent. Well, what do you think the isosceles trapezoid is going to be like? The base angle is going to be congruent. Okay, same thing with the ones on top. Okay, the ones on top will also be congruent. Okay, so just like an isosceles triangle, the bottom angles are congruent, the top angles are congruent. Consecutive angles, so what I mean by consecutive, are one right after another because these lines are parallel. Just like the trapezoid up top, these angles here equal 180 because they're those consecutive interior angles. Same thing over here, that's also going to equal 180. So just to keep that in mind. So we got the legs are congruent, we went through that. The common base angles are congruent, we got through that. And then uncommon base angles are supplementary. So those are the ones that I circled in green. Those are supplementary. And then the last one is that the diagonals are congruent. So in the regular trapezoid, the diagonals are not congruent. They don't bisect each other, they don't do anything. But in the isosceles trapezoid, the diagonals are going to be congruent, but they're not going to bisect each other. So that's what's different about the parallelogram. Those figures. This is not a parallelogram, but the diagonals are going to be congruent. So this length is going to say that this is 10. That means this length is going to be 10 as well. Okay, so I think I got everything in there. If I didn't and I mixed over one thing, go ahead and just flag me down and ask what it means, and I'll be sure to answer it. So, like I said, just wanted to make sure that we understand this. Once a property is listed, it will filter down through all the shapes. So we went over like that first one, and especially in the parallelograms, if it's listed above, it also has that property. So a square has a property of a rhombus, has a property of a rectangle, has a property of a parallelogram, and it also has a property of a kite. So you got to get really good at these, and we will, because we're going to practice them a lot this week.